Okay, so we're going to continue with NodeMCU ASP8266 web server. And in your previous class, you've learned how to connect to a Wi-Fi. And then that's what we call as a Wi-Fi mode, which allow for your ESP to connect to a Wi-Fi access router. And the second method of connectivity is what we call EP mode, which is access point mode, which turn your ESP into what we call as a web server and are able to respond based on requests. So this is basically mainly used in configuration, which allow you to access the web server, which turn your ESP into a web server, and then you can load configuration, you can store data, you can set up parameters, or you can even start and stop any services that you allow for the application to work. So there's so many things that you can do with EP mode. And in this example, you can see that the ESP8266 Wi-Fi library is being used to enable the server mode. All right, so this is what we call as a server mode. First, we need to import ESP8266 Wi-Fi, and then we need to define the access point name. You can give it any names as long as it follows the standard naming convention. And then you can set a password. If you leave it empty, the password will set empty. And then we create what we call as a server object through the use of ESP8266 web server class. And your server object run using what we call as a port 80. So usually port 80 for a web server, for web document. So we run this at port 80. And in this configuration, we have, actually you can put it at the bottom because you should start with a void setup. So the void setup basically just to turn your access point mode into AP mode, which is by calling the soft AP function and pass SSID and password, which automatically enable your AP mode. This is just to print out. There's no need for you to print out actually. And then at the bottom down here, there's an object.begin, server.begin, which is your server here. So when you turn on server.begin, the handler, the HTTP handler, which is the root handler through slash, when you use or when you call the IP address 192.1.0.4.1. I forgot the IP number already. What is it, the IP number? Okay, 192.168.4.1. Okay, so they usually given you with this IP address, but you can change the IP address later if you do you like the use of this IP address. But by default, this is the IP address. Okay, so how do we deal with this? And this is where you define or you create your HTML page. Okay, so when we turn on our server here through the void setup, any request made through the root HTTP request will be handled by the handle root function. Okay, so there's a handle root function there. So this handle root function is up here. So whenever it is being called, the handle root will be implemented, and whatever that we have inside here. So this is your return page. Just a very simple HTML return page. Welcome to NodeMCU AP. So it means that you call root, this will be written. Okay. Within the loop function, you need to implement listener. So this is the server listener. So whenever the SP run, and it will listen for any client request through the handle client. Okay. So for example, like if we implemented this, so I'm going to create new one. All right, so this one is the access point mode example. So I'm going to call it AP mode example. Give it a try. Try to compile first, and then you can upload. Oops, sorry. Server. So this is server. This is server. Bottom down here, server begin. HP server didn't have it. Oh, I think I'm missing the other library, the another include library that I didn't put here. I think I've missed that out. Let me just access that. There's another library that I didn't include here. Hold on. I think the library is this one. Forgot to include this, and the client also. This one. Forgot about that. I didn't include that properly there. So compile that one more time. Web server template, table type, handle root. There's new update, compilation error, template begin void. Hold on. Speed. Okay, so I believe they have updated this, the latest version for the ESP8266 with a new function. The one that I use no longer. So as we can see here, this is Wi-Fi begin. This is server begin constant void, SHA-2 void. All right, so let me check the library first. ESP8266. The version that I use. Hold on. This is also another problem that you might encounter with library. So sometimes the one that you use, the new version, they are no longer works. The older version of the library, they didn't allow you to use that function. So I might need to check on this. So it doesn't seem to work on the latest version. Let me check on that. So the things that you have to understand. Oh, this is the. Just want to check the setup mode. Because usually this does work, but things will happen. Things will break. Okay, so trying to solve this, calling ESP, no matching. So try to get this one. Handle root. This is handle root. This is handle root. Server begin. Do I need this? No, not this one. It's supposed to be straightforward. We try to use ESP8266 AP mode server. How can they use different library now? They use ESP async web server. So they've changed to a different library. So the one that I use, I'm not quite sure if they still work or not. They're supposed to work, but Okay, let me just use the one that I already have. TDS meter. I think this one, TDS meter. I don't want it to TDS meter. Let me check the one that I use here. So the one that I use here is webserver.h. ASP web server, HTTP client. Oh yeah, this one. I think this one, not the Wi-Fi client. This one being used for ESP32. Hold on. No. Check one more thing. Wi-Fi, this is correct. ASP Wi-Fi, ASP web server.h, ASP client.h. The rest is no problem. I just want to use this one and this one. Okay. Namespace, a little bit difficult if you're not familiar with namespace programming. So let me just use the one that's simple. Same. Okay. This one just to ping out. Hold on. Within the loop, AP mode, server client handle, same. Server client handle. If this is AP mode, then turn on AP mode. Okay, so this is AP mode. Constant char, password, Wi-Fi mode AP, SSID, print mode. Okay, so I think I'm going to take this one. I'm going to remove this one first. Then I'm going to take this one, soft AP mode. And then this is just to launch web, create server, server.begin. Okay, this one is server.begin. AP mode, serial, launch web. Just give it a call. Server.begin, sorry, not here. Server.begin should be here. This is HTTP request. This is to upload data. This is to create web server. Okay, maybe I can just use this one. Handle root. I'm going to create a simple web page through content. Create web server, handle root, client requested, server.send, server on slash, server send. Teacher, hold on. I'm not quite sure why the one that I use here doesn't work anymore. But this is the one that I use on all my project. But this is basically, they're basically the same. Just don't have any idea why that one doesn't work, because basically just a simple page request. But the library doesn't seem to work anymore. This library here. The problem is with this library. So it's supposed to create a web server, but it doesn't. It does seems to have issues with the method, the function that I use. So I might need to change that to a different one. So usually the method that I use is this method. Okay, the one that I use here, just to create the access point mode, and then to create okay, so read data, delay, create the access point mode, AP mode. So this is the AP mode. Straight away, get it from here, here. All right, we're going to take from there. Serial, reline, delay, Wi-Fi, print. Okay, so Node MCU server. Set AP mode. Done. Then call a launch web. Create server web type. So let me just create simple server first. So this is my server. I'm going to remove that. Go to create server. If web type equals 0. And then server on slash. So if server on slash, do this. And we create our server content here. But the content of the server is quite long. So I'm going to use a simple one. This one will return a HTML form. Okay, so we'll return HTML form. So I don't want to return HTML forms because it's going to be longer. So I'm going to create just a simple HTML tag. And then inside we have like head section and close the head section. Inside you have body. And then you have close body section. And then inside body, you have your, let's say your header2 slash header2. Welcome to Node MCU server. Okay, just a very simple web page through content. Okay, so that's all the content that I want to work with. So I need to close that content with server.send. Send what? Send the content itself. And then close the request through close. There's only one request here, web type 0. All right, I think that's the only thing that I want to work with for now. All right, so, and then we call the web server and then launch the server. All right, so launch the server, create the web server, call it down here. So I'm going to call it straight away down here. Create server. So within loop, we're going to handle client. All right, so let's see if we can get it to work this way. Oh yeah, the web type, I forgot to provide web type. So web type 0. We pass web type 0 here. Forgot to do that. All right, so let's see if I can still compile this. Oh yeah, content, define content. So content is a string. Content equal empty. Okay, one more. AP mode equal true. I did take that. Okay, this one no need. I'm going to remove that. Okay, one more time. Compile. Okay, seems to be okay. Yeah. Okay, so now I think because of the update of the library update with the new version, it doesn't seem to work the one that I used before. So before this seems to be working just fine. All right, but this is the new one. Okay, this is the new one that the one that I use. And here what we have is basically, I need to change this one because the one that I use here is different. So I'm going to take this one and then replace them here. All right. Verify them one more time. Okay, that should be okay. All right, so what we have here, okay, this is basically the latest update. So up here, this is where we define the server name. So our access point name. So the access point name here is Node MCU server with empty password. And this is the same object that I've created. And then down here, inside the setup mode, we have our serial begin with our baud rate. And this is just to print out on our terminal, which when user connected to our access point mode, we need to enter this IP address, which is the IP address of the server itself. Turn on the Wi-Fi mode, which is a Wi-Fi access point mode. and then use the soft AP to create the server name with the server name, SSID, and pass IP. And then this is just to print out the IP address. You can just remove them. And then we need to create our server. Okay, we need to create our server response. So the server response basically handled by this function, and this function basically just send out web type 0. Web type 0 means that this is basically I just want to turn on. There are two types that usually that I enable, 0 and 1. So if it returns 0 means that I want to handle in here. If I have web type 1, so I have another one, another if statement that I can handle another type of server that I want. So at the moment, I just create one server. So in fact, you can just remove this. There's no need for this and just respond everything through server on. Okay, so like if I don't want this, there's no need actually for this for now. So just remove this one and this one. And we don't have even to pass the parameter, this parameter here. Okay. So try one more time. Okay, it should work now. So we create our create server here and then tell the server to start. But the server require server handler client to listen to the connection. Okay, so it will basically loop forever and wait for the server to respond. So if the server respond or any request made by client through slash, means that it will basically return this content back to the server. So let's try to run this and let's see if we manage to get the server to run. Okay, port number, and MC. Start again. I think the connection here a little bit loose. Nothing. And so not MCU, right? So version 1, press OK. Then try to upload. Okay, connecting, uploading. Okay, so let's try to reset. Okay, so please connect to this. So as we can see, we have our non-MCU server here. So if you want to build, if you write this, please change to a different name. So the one that I use here is non-MCU server. So if you use the same name, then it will be duplicated. So this is mine. So I can connect. Okay, done uploading, and then go back, connect. So this is use, okay, this one. I'm going to change this. Step. Oh, yeah. So make it a little bit smaller. Still the same. And with no smaller. Mm, smallest that we can go about 10. All right, should be okay with 10. Okay, close this. So this will be updated. So yeah, should be okay now. All right, so I'm going to push this to my server, put it in GitHub, and then you can just access from there. Sensor, this one updated with AP mode. Come to main, push. Okay, so you can get the code from there and then give it a try, but make sure to change to a different server name. So instead, the one that I use here is not MCU server, so you might want to change to your name or whatever names that you want to use. Okay, so I think this one is very straightforward. And usually, when do you use this? If you want to do some configuration, if you want to configure your ESP with like setting for AP name. So if you want to change to a different AP name, so you can basically store the data. You can create a form here. You can create a form through there, and then you can just pass form, and then the form basically can receive back the data, and then you can save the data into EEPROM. And then later you can load the data from EEPROM, and then you can change to a different name. Okay, so it can be used for so many purposes. And then you can just create response. Okay, so based on the response here, your web server will be able to load data based on user request. Okay. Okay, so this is AP mode with web server. Okay, so you can use AP mode with web server, even if you want to create your own page here. But you need to be familiar with web programming with HTML, CSS. But I'm not quite sure JavaScript can execute this one or can be used here or not. I think you can, because JavaScript based on a request running on your browser. So if your browser supported JavaScript, should be able to run the JavaScript here also. So this is just a normal HTML server. So anything that requested by client based on the route response of the web server here, you can easily access them. Okay. So even you can pass back the data to the web server so that the web server can process. For example, like the one that I use here, the one that I use here in my hydroponic 2 is one of the project. So for example, the one that I use here is basically to configure router. This one HTTP request, HTTP here, this one. So you can see there's a long HTML here. So this HTML basically to create a form. Okay, so let's try to see the output of this content. So let me just put it here. So the content here, I'm going to replace, let's say this content here. Okay, I'm going to paste that. So this is just HTML, a bunch of HTML code. Okay, just a normal form. So let me try to upload this code again. Oh, I need to define a few things here. Dev ID, SSID, and password. So I'm going to take that variable The variable is this one. So no need to define this. Okay. Still recording. Still. Okay, done. So let me try to connect again to this. Your SSID, if you want to change to a different SSID, you can. So instead of the known MCU server, you can change to a different name. Okay, through the configuration, through the Wi-Fi configuration that we have here. Through here, you can load the data back. So the data will be here, and then you can either save back the data, and then you can put all the data there. Okay, so this is what we call as web server. Okay, local web server. Okay, you can use the example that I already uploaded through the GitHub. Okay. Any question? Ada soalan? Kalau siapa-siapa nak pakai ESP, boleh request, boleh minta dekat Naufal. Dia dekat situ. Okay, kalau siapa-siapa nak pakai lah, minta kat dia. Okay, straight away minta kat dia. Tapi nanti pulangkan balik lah. Ha? Okay. Oh, ada satu benda yang saya terlupa. Button. Button ni, you can use button as an input, which allow for your application to react based on the button. Because for hardware programming, hardware device programming, the way that you provide input or you provide interaction with user is through button press. When user press button, and then they can interact with your application, either to provide as an input value, or even you can use a press button to input numbers 1, 2, 3, 4, 5, 6. You've got a press button there to provide value. Okay, so those are some input that you can provide for user. So that can be accessed through digital pin, and then you can just use them as an input. Okay, set the button as input. Okay, so we have done that, and we're going to use this in a project in an example application later on. If you want to use this in a Wi-Fi mode, also can. You'll be able to use this as a Wi-Fi in Wi-Fi configuration, which means that you can connect, for example, to UEM Wi-Fi guest, and then you can get the IP address, and then you can use that IP address as a response. Okay, so either as an access point mode or as a Wi-Fi mode. So in Wi-Fi mode, you are basically connected within local area network. So as long as you are connected to the same network, you can access them. Okay. But in this mode, which means that you want for others to be able to access your device. Okay, because you are connected to a router. So the one that we used before, we need to enter this IP address here. This is IP address of the device, but you have to connect directly to the access point. Okay, you have to connect to this directly. So which means that the only IP address, if you don't change, the IP address will always remain 192.168.4.1. Okay, so it will always that IP address. But if you use the Wi-Fi mode, you don't have to, as long as you are connected to the same Wi-Fi network. So like, for example, I'm connected to UM Wi-Fi guest. You are also connected to UM Wi-Fi guest. If you connect to, if the device also connected to UM Wi-Fi guest, you can access the web server, the local web server as this. Okay. So if that's what you're looking for. But usually, when we do this, what we need, usually we just use this to be able to do some configuration, okay? To store SSID, to store password, to store device ID, or to store any data permanently or not permanently. You can store the data into the device EEPROM, okay? So again, the example that I use in my project, I just store the value into access point mode. And then from there, I use the EEPROM. As you can see, there's an EEPROM library here. So this is what we call as an EEPROM library. So EEPROM library allow you to gain access to the storage, to the local storage. So the local storage here, like for example, if I want to read data, so I just call this function read data. So this is the read data function. So this function basically allow me to read data from EEPROM. So what we have here is just EEPROM begin and set the address. So 512. So it basically will start from 512 address location, and then we can just loop each memory cell. So for every cell, it basically allow you to store one character. So there are 20 characters that I store for SSID, 20 characters that I store for password. Sorry, this one is SSID. Sorry, this one is ID. This one also SSID. This is password, and this is at the bottom down here for the device ID. Okay, so there are 3 memory location that I use here. So each memory location 20 bytes. So one character we can store one value. For example, like A, B, C. So one for A, one for B, another one for C. So through here, I allocated 20 characters for SSID, 20 characters for password, 20 characters for device ID. Okay, so divided into 3 sections. And then this is just to read the data. To write the data also the same. So if you want to write the data, so we just use EEPROM, but I have to clear all the memory first and then write the data. So to write the data, just give the instruction EEPROM write and the value that we want to write. But it has to be in char character. Okay, so there's a 1, there's a 2, there's a 3 data. So one for SSID, one for password, one for device ID. But device ID is a little bit overkill because the size of the ID usually like 3 character, 4 character long. So actually there's no need for you to store that size, that amount, because it's just a waste of memory. Okay, just a waste of memory. But here in this case, I just use 20 character, 20 character, 20 character. So evenly divided the memory into 3 sections. So this basically allow you to read and write data from EEPROM. So the data basically, as you can see, there is a function write data, string A, B, C. So which means A for SSID, B for password, C for device ID. So we loop the data and then use the EEPROM write with the location or the array of the memory. Okay, so array. So those are basically the logic that I use to write and read data from EEPROM. Okay, very simple actually to use. Just use EEPROM.begin, EEPROM.write. To read data, EEPROM.read. Just use EEPROM.read. But you have to convert this into char data type. Okay, char data type. Single character data type. Okay, but we're going to use this later. I just want to talk about this and give it out to you for you to understand if you read my codes. Okay. Read data. To clear data, usually I clear all the data again back in the memory. So this is just to clear 512 size of memory. So it means that I can store 512 characters of data. Okay. So anything more than that, actually, no, I won't recommend you to do. Okay, so this is basically the size of data that I usually store in the EEPROM. So as long as anything less than 512 character long, you should be able to store this into your EEPROM. And normally you use this to store Wi-Fi SSID, Wi-Fi password, or any small configuration data. You don't store the entire book inside EEPROM. Okay, that's not what it is for. It is for configuration, for setting, for small data type. Okay, you don't store a lot of data inside here because the size of the memory is very small. Okay. Okay. So this is basically ESP8266 communication. Okay. So many things that you can do here. For example, if you want to on and off, you want to provide an on and off command. Okay, you want to turn on and off something. Okay. So like for example, the LED on this device. So this is the example that I use. I think this is the one that it still can work. Let's see if we can work this out. This is low, this is high. Seems so. We try this one. So this one I connected to ESP to the Wi-Fi. Like let me take this one and create new one. And I'm going to talk about this. Right. So one of the example that you can use. This one. Let me call Wi-Fi server LED. Okay. Try to compile first. Let's see. I think this is should be okay. But this one connected to UM Wi-Fi guest. Okay. Hope so. Yeah, still work. All right. So let's see about the code first. I'm going to remove most of the serial.print because there's too many things of them, making things rather complicated. No need for this connected. Okay, this we need this because we want to know the IP address. Server on and off. This is just LED on, LED off. Server begin. Server started. So we set the pin mode D0. D0 means that the onboard LED. This is on. This is off. Okay, this is server client. Okay, simple code. So let me try to upload this. Okay, so let's try to connect to UM Wi-Fi guest. Okay, so we got the IP address. So this is the address that we're going to use. I'm going to copy this and I'm going to put it into my. So if I just put like this, nothing happen. If you can connect to the server, but the instruction is that either you need to provide on or off. Okay, so this one is on. Should return something. But if you're on different network, we cannot do anything. Sometimes the IP address when you connected to the router, let me check my IP first. Sorry. CMD, IP config. So my IP is on 105 network. So the one that provided here is on the 6 network. So 10.19.6. Yeah, I cannot access the IP address. So that's the issue here. Because I'm on this IP address. So this IP address is on different network. This IP address is on network 6, this one on network 105. So I cannot communicate with this because even though it's connected to the same Wi-Fi network, if you understand how routing works, when you configure routing, there's a lot of what we call as a virtual segment. So the VLAN, we call it VLAN. So I'm on different VLAN, even though connected to the same Wi-Fi guest, but the VLAN created inside the router, they separated this into multiple subnetwork. So I'm on a different subnetwork, even though this can be connected. Supposed to, because the IP address I provided here is this. This is the IP address. This one, this is the IP address of this. So if I give a command off, so let's try that one more time. If we are able to communicate with them. So this is off. I'm unable to respond. Okay, because of the IP address. If you're on the same network, so for example, like if you create your own Wi-Fi and using your phone, the IP address should be like within the same network, and you should be able to communicate with them. But in this case, should be able to communicate, but no, because of different IP address. A different IP address, but I think I can provide static IP address. Let me try to provide static IP address. Means that I'm going to follow my address here, which is everything at front here with the, let me just try to do that. Static IP address. ESP8266 set static IP. Okay, but static IP address can be quite dangerous because sometimes you override someone else's IP address. You are running on the same IP address as someone else, so you might have issues with that. So I hope, let me try to get that IP address static. Server static local IP. No, this one is Wi-Fi local IP. Not this one. IP address local IP set static IP address. I think we can use this one. Wi-Fi config. Oh, I need to provide all the information. Okay, I need to provide all the information like this one. So if I wanted to set the local IP address, I need all these, all the subnet and everything, and then override them. So, but I need to know the IP address for now. So this is a subnet mask is this. This is subnet 255 to 128. Okay, so this is 128. And then my gateway is 10.19.11, 10.19.11. My gateway is 10.19.11. And then the IP address, I want it to be within the same network, 10.19.105, 10.19.105. But the IP address at the back here, this is if someone else on the same IP address, there can be like collision of data. All right, so let's say set the IP. So if I want to config, so this is the config that I need to provide. Okay, first, that's the configuration before I can communicate. So that's the IP address. So let's try to compile them. No. Primary address not declared. So I missed one more items. The primary DNS, this one. It's really optional. Maybe it should be optional. What is? Primary DNS. So the default one, this is primary DNS, secondary DNS. So I can just remove them. There's no need for this actually. I just want to set this tree. 1 tree, right? So let's try if we manage to use this. Okay, so that we can control the LED here through web browser. All right, so let's see serial monitor. Yeah, we can have this IP address now, 10.19.0.184. So let's see if we can use the IP address. One oh one eight four slash off. Supposed to respond, but I'm forcing the ESP to be able to have this IP address. Is it the same one? 10.19.240. Didn't return anything. Oh, no. This one is 184. 10.19.105. 10.19.105. 184, right? 184. Oh no, the IP address provided here is 6210. Let me just reset that one more time. This server started. Okay. Should be able to use this unless the gateway or the provider of the IP address didn't allow me to use this actually. But I'm forcing this to use it. No, I cannot use this. It didn't allow me. The server the IP gateway provider, the one that provided the IP address didn't allow me to use static IP address. Okay, so but this can work if you're running this on your own network. Okay, different network, no, they don't allow us to set static IP address. Even if I try to ping this, try to ping to the address, nothing. Unable to request. Okay, didn't return anything at all. The IP address is not there, or maybe someone else used this already, or being assigned to the IP address, maybe. Okay, so even though my IP address should be within the same range, same. So 10.19.105, 10.19.105. So this is the address that I'm using, 182. But the one that I use here is 184. Maybe someone already used this, so let me try to different IP also. Let's say like 222. Is it possible? The max IP address is 225, right? So 250. Forgot the max. Let's try 222. Okay, server started slash off. Didn't respond also. No response from the server. I believe UEM gateway didn't allow us to use this. Okay, didn't allow us to set static IP address. So even though we try to set a static, it won't allow me to use it to use the address. There's an address allocator for the IP address. It will dynamically assign IP address connected to the network. But if you try to force your own IP address, it won't allow you to do it. Okay, so try to use this, doesn't work. Okay, so that's because of the limitation of the network that we use. So you should be able to provide on and off. So if you provide on and off, it basically will turn on your LED or turn off the LED. So basically it provide you some sort of control to the controller, to the LED. But no. Then 19 105 222. Return nothing. Okay. RT out. RT out. Okay, but that's basically the idea. Okay, that's basically the idea. But I try to provide with that. It run on different network. When it run on different network, doesn't allow me to, even though I try to set to use them, no, nothing works here. So might as well just, if you want to test that, you can just use them through your own network and gain access through your local network, through your own network. But if you have given with the same network, that would be great. But it didn't work. But the idea is that something like this. Okay, you should be able to provide access to the digital write to the LED. So what we have here, as you can see, digital write D0 low, which is LED on, digital write D0 high, which is LED off. Okay, and this server client basically will handle that. But if I run this through local through the AP mode, should work. So the AP mode here is basically the one that I have before this. You can just use them, the previous example that I have. Wi-Fi example, AP mode example, Wi-Fi example, AP mode example. Oh no, this is the AP mode example. Mode 16. Okay, so let me try using this one. Mode 16, which is for LED, set as pin mode. And then if we provide the command here, so we just want to have for the LED to turn off and on. So LED on, which is low. So I'm going to create another server, which is for on and off. So let's say this is on. Going to give it LED on. And then provide the command to turn it on. So this is just to turn it on. So this is 16. So this is on. And this is on off. So I'm going to use a local network. So this is off. So LED high, digital write. Okay, so let's try that. I just want to demonstrate be able to turn on and off LED. So this one should be off. So set high, set low. Okay, one more time, upload. And then connect. Siapa dia ni? Hello, no, yes, today sleep. M pun ada, aimless. Okay, so restart server. Okay, server saya. Push. So I just use this one. So this one basically the route. Okay, the route for the HTTP request. I just put in digital write 16 low. 16 is the LED here. The other one is 4. This one is 4, I believe. The upper version is the upper top LED on this PCB here. This is 4 or 0, 4. This one is 16 at the bottom down here. So when I give the instruction over there, digital write 16 low, digital write 16 high. So when I put it slash on or slash off, it will basically execute whatever that we have inside here or whatever inside here. So what we have here is just turn off LED and then return back respond LED on, and the other one turn off LED, return back HTML content LED off back to the browser. So it means that you can use your browser. Even you can connect to mine and you can give it a try, but it will try to whatever command that you provide, it will basically execute them. Okay, but this only work with a direct access point mode, which is must be within the same within the reach of ESP. So if you're on different or if you're far away, you cannot access this, definitely cannot be done. Okay. Okay. Alright, so kita dah belajar berkenaan dengan basic web server. Ini just basic web server lah. So di mana kita punya our ESP here, we can turn this into a web server. Okay, which basically allow us to do many things. Okay, we can provide control, we can provide response page, we can set up our initial configuration. There's so many things that we can do with a web server. Okay, so next, this is basically one of the example that you can use, basically just to store your EEPROM or to store your data into EEPROM. Okay, to store data into EEPROM is that on board here, there's a EEPROM memory. So inside here, inside this, behind this metal case here, there's a EEPROM chip. Okay, this EEPROM chip allow you to store data. Okay, your programming, whatever that you code, basically written into the 4 meg of storage inside here. But there's another memory inside called EEPROM. So this EEPROM can be accessed through your programming. Okay, which basically you can use them to store data, but you can only store data, limited amount of data. Okay, and usually you store configuration data. You don't store a lot of things. You don't store image. You don't store complex data. Just a simple data. Okay, so to be able to access to the EEPROM, okay, so here this is a sketch for you to use. So the first thing that we can use now here is to write data. There are two things that you can do. You can read and you can write. Okay, so the way that you read data, actually you need to start with write data. Write data means that you want to clear things from your ROM. So if you use the first code here, this basically will write. This one is write data. Yeah, this one basically will write data to your EEPROM. Okay, so as you can see, the codes here, it start with, you need to include the EEPROM library. Okay, the EEPROM library called EEPROM.h. And then begin EEPROM begin 512. This is basically the address location for the EEPROM, starting from 512. And then there's a function down here called write data. So this is just a simple instruction to write data straight away into your EEPROM. So as you can see, the function write data down here, this is just the printout. So this is the data that we want to write into the EEPROM. Okay. So for example, SSID is EM Wi-Fi gas, and the password is empty. So actually, you can just put any data here. So to write the data into EEPROM, you can just use the loop here. So usually I just use the rule of 20. So 2020. But unfortunately, if you use if your data longer than 20, means that you cannot store the data here. You might need to increase the size of the data that you want to write. So usually anything less than 20 or equal to 20 should be just fine. For example, that SSID. So SSID, anything longer than 20, definitely no. Okay. So this is very simple. There are two data that we written here. One is for the SSID and the other one is for password. Okay, so it means that we want to write the data, these two data here into this memory. So EEPROM write, so we loop the data, we loop the password, we loop the SSID string data. Okay, and then finally we need to commit the operation. So we just put EEPROM.commit. So it means that it will finally write the data into the memory. Okay, just like that. And then write successful. So if you use this code, it's basically should be able to do that. EEPROM example. One. Okay, put it into the okay, try to verify the code first. Okay, should work. And then okay, so load. Oh, no port provided. Again. my main block. Okay, select this one, and MCU 0, select OK, and then upload. What's going on? 0 port used. Sometimes this also happen. Let's try that one more time. Exit status 01. Okay, uploading. So something like that will always happen. So don't you might have to wiggle your cable here and there, try to make it to work. If you didn't see your ESP port number at all, means that either your cable is busted or your ESP is the one that having issues. So that can be unfortunate. All right, so let me try to reset them. Oh, I didn't put any oh, there, level 5. Write data. Should print it down there. 5. I didn't call write data. Should be able to write and print out the information. Again. Oh, there. Writing to EEPROM, write successful at the bottom down there. Writing to EEPROM, and then at the end there, write successful. Okay, so everybody's just writing the data, then you need to load back the data. So how do you load back the data? So the next code here, this is basically to read back the data. Down here, read the data. So read data, you just read data from EEPROM, and then you use the two variable there, SID, Wi-Fi password. Not quite sure why I put the names, but yeah, the two data that we load, and then we just print out back the value that we read from the EEPROM. So when we read from the EEPROM, basically just use the EEPROM.read and use the I there, and we loop for 20 times. Okay, we just loop for 20 times, and then whatever that tick coming from EEPROM will be assigned into the EESID and will be assigned to the E-Wi-Fi password. Okay, so char EEPROM.read will read loop for loop, and then at the bottom down there, just to print back what has been written into the EEPROM. Okay, just like that. Okay, is read, and then I'm going to print out the value. Okay, so this is SSID. This is a password. Device ID, no. SSID, and password. And then reading from EEPROM, SSID and password. I don't have the data there. Put the data up there. So I'm going to put it as a global variable. So I'm going to put it up there. So this is the data that I want to store. So let's say the password is ABC123. And this is the two data that we want to store back into database. So read, write, right. So you want to call the read data and then call from here, read data. So we just put a serial.println reading from read EEPROM. Okay, so this one is writing up here, write data, write data to EEPROM. Then put some delay there, just 500 millisecond, just to provide enough time for the ESP to cool down a little bit. There you go. So verify them. Okay, should be okay, and then upload. Date log, write data. I want to write data to EEPROM. Write data. Read data. But yeah, it should be okay. So let's see. Throw a serial and then try to reset. Okay, so you can see those the data that being written and writing. So writing to EEPROM, successful reading from EEPROM. So when it try to read from EEPROM, it will print out the value that they have from the EEPROM. So here inside here, I have read data here. So the read data is here, the write data is here. Sorry, the read data is here for the password. This is for SSID. This is for password. And I think I print out the value inside here. Read I. Yeah, I think I print out the value. So that's why you get this. You get this print line for every of this. But as you can see, the one that I've written being read from EEPROM, this one. But there are two written. Oh yes, double. Because I've given the names up there, and then it should be only inside here, inside this SSID password. So let me try. This one is eSSID, means that it is for eSSID. And the other one is ePassword, and this one is eSSID. So I'm going to define it locally inside this function. So string eSSID, epass. Okay, so it means that local variable in here, read and write, so that I can just distinguish differentiate them easily. Okay, and I don't want to print out for every loop, so I'm going to comment on that. And so comment on that. Upload again. EEPROM, there's a limit that you can print, you can write data to EEPROM. So I believe the limit is 100,000 cycle. You cannot write more than that because it will become problematic to be able to write to them. So you can see them. Yeah, there you go. Okay, done. But the password is not there. I think the password pass. Oh yeah, this one is 20 pass I. SSID pass I. This is pass ABC 1 to 3. This is pass. This is SID. EEPROM write 20 to 40. 20 to 40 read I. ePass plus reading Wi-Fi SSID. 20 to 40. 20 to 40. But this one didn't store that into, what is it? This is the data. This is the data. Should be okay. Why didn't properly return into the, ada saya salah tak kah? Read data, write data. This is write data. Oh, minus 20. I didn't put it there, right? Yeah, saya tak letak. Saya lupa letak. Should be minus yang ni. Minus 20. Pass I, B. I value ni. Kat sini saya lupa kot. BI tolak 20, B value. Right data. So saya tinggal yang ni. Right. But this is the value of SSI password. Saya silap yang ni. Itu saja. 20 character long, 20 character long. Oh, yang bawah pun sama. Yang bawah should be okay. 20 to 40. Okay. Yeah, betul lah. Betul. ABC 123, Wi-Fi gas. So both data basically comes from EEPROM. So this data down here. So let me just clear this one more time and then reset. Okay, so rating to EEPROM, write successful, reading data from EEPROM. So reading from EEPROM, reading Wi-Fi password, this one, and then this is the data from EEPROM. So you have UM Wi-Fi gas, ABC123. So this is basically the one that we've written here. Okay, but if you combine this with the web server, then you can use this as a method for you to change your Wi-Fi SSID dynamically from your server form. Okay, all right. So read data, write data function. Okay, so there's nothing inside the loop because I don't want to loop this operation. This is an expensive operation. Because you write data into EEPROM, there's a cycle that you cannot exceed. Okay, so you don't want to break that cycle. Even though the cycle is like 100,000 cycle, but still the value is still there. And then if you written more than that, you will corrupt your memory corruption there. Right. So you don't want to write the data too many times. But if you put inside loop, definitely will do that automatically for you. Okay. So everything inside setup, one is write data, one is read data. So the only thing that you want to change later on, you can provide this data dynamically from your web server there. Okay. Okay, so those two functions are very, very simple to use. Right, so let me just push them. EEPROM. Banyak pula saya punya git push dah ini. Okay, so give it a try. You should be able to use them already. Okay, so any question on this? EEPROM? So the data inside here permanent. So if you take it out and then if you connect back, basically the data will remain here, even though you don't have any power. Okay, even though there's no power inside here now at the moment. So if you connect again, it will basically load back the data from the memory, EEPROM memory, and then you can use the data for whatever purposes of your device. Okay, so very, very important functions to use later in the project. Okay, so your lab assignment 1,